Okay, so number 5, a mixture consisting only of lithium chloride, lithium carbonate, and lithium nitrate was analyzed. The elemental analysis of the mixture is revealed the following. So I have lithium at 14.19%, chlorine at 10.56, carbon at 6.19, oxygen, and then nitrogen. The first, it says calculate the mass percent of each compound in the mixture. So you're probably like, where do I even start? I don't even know where to go. Anytime that you have a mixture and they're giving you percents, your first step is to isolate, right? So like, what is something that you can isolate? I have lithium chloride, I have lithium carbonate, I have lithium nitrate. So I will notice that lithium is in all of these. If lithium is in all of them, I'm not going to be able to use lithium because I don't know how much lithium chloride I have because you have lithium in the other two. So this does not make sense to use that, right? So this 14.19% is kind of scattered between these 3 compounds. If I look at chlorine, I can use chlorine because chlorine is only specific to this compound. So I'm going to use chlorine. In terms of lithium carbonate, carbon is very specific to this compound. So I can use carbon. I don't want to use oxygen because, again, your oxygen, this 59.06, means that I have that much percent in both of these compounds. So I don't want to do that. And then nitrogen here is isolated for this compound. So I can use these percents, hold on, chlorine, carbon, and nitrogen in order to determine how much of each compound I have in the mixture because they are specific to each one of those compounds. The second thing you want to do is you have to assume that you have 100 grams. So all of these percentages can be turned into grams. If you add up these percentages, they equal 100. So we can assume that you have 10.56 grams of chlorine, you have 6.198 grams of carbon, and then you have 10.01 grams of nitrogen. The third thing that you want to do is you're starting with your given. So because you have to find the mass percent of each compound, which means that you need to get the mass of each compound before you get the total mass of the mixture, right? So if we're assuming that the mixture is 100 grams, we have to figure out the mass of each compound. So first step is the mass of lithium chloride. I just told you to use chlorine, so we're going to use 10.56 grams. So as you see, 10.56 grams. T-chart, unit goes diagonal, and we're always going to mole. So 1 mole is equal to the molar mass. Yay, I got some mole of chlorine. Now what do I do? Once you get to a mole, right, so I have a mole of chlorine, but I'm looking for the compound. How much compound do I have? If I'm staring at the compound, and you learned this in honors, but it was like a 2-second teach, so you might have forgotten, you can say I have 1 mole of lithium per 1 mole of lithium chloride. I have 1 mole of chlorine per 1 mole of lithium chloride. So because I already know that I have 1 mole of chlorine, as you see down here, I can go ahead and say I have 1 mole of chlorine per 1 mole of lithium chloride. So I extend that T-chart, and then I can just finish off by getting the molar mass of lithium chloride. Once I do that, I get my molar mass of lithium chloride, and then I have a 100-gram sample. So by getting the percent mass for that, I just divide it by 100. What I do? I don't think you divide it by 100. Do I have to divide by 100? Because 12.63 grams. No, it would just be you're taking that and you're putting it into a percent. Ignore me for that because it has to equal to 100. You're not going to divide it by 100, by the way, because that will not equal 100%. So ignore this part. You just have the 12.63% of lithium chloride. Second thing is now we have lithium carbonate. So again, we're starting with the carbon because it's specific to this compound, and we don't have to figure out what kind of percent we have in each of the compounds. So I have carbon, I have 6.198%. So again, I'm going to do the same thing. 6.198 grams of carbon. T-chart, unit goes diagonal per 1 mole. Now I'm stuck at 1 mole of carbon and it's asking for lithium carbonate, right? I need to know how much compound. So I can say that I have 2 moles of lithium per 1 mole of lithium carbonate. I can say that I have 1 mole of carbon per 1 mole of lithium carbonate. I can say I have 3 moles of oxygen per 1 mole of lithium carbonate. Because I've isolated the carbon, I'm just going to say it's a 1-to-1 ratio. So here I draw my T-chart, 1 mole of carbon per 1 mole of lithium carbonate, and then again I draw my T-chart, 1 mole goes on bottom, and then the molar mass goes on top. You're not dividing this by 100, by the way, because it's a 100-gram sample, which means that this is your percent out of 100%. So it's 38.13%. And then lastly, you can solve this 2 ways. You can either take 100% and then subtract the 2 answers that we just did to give you 49.26% of lithium nitrate, or you can do exactly what we've been doing. You go ahead and you say, okay, I have nitrogen, which is specific to lithium nitrate, so I can isolate it, and then I can go to the compound. I start off with 10.01 grams. I do the molar mass per 1 mole, and then I have 1 mole of nitrogen per 1 lithium nitrate. And then you finish with the molar mass, and that should give you 49.26%. And then the last one is a sample of mixture containing an unknown hydrocarbon. So remember, hydrocarbon is just C's and H's. So typically you'll have some kind of C, some kind of H. And some nitrogen dioxide had a total mass of 31.25 grams. The mixture was analyzed using combustion analysis, producing 78.44 grams of carbon dioxide and 32.12 grams of water. Calculate the empirical formula for the hydrocarbon. So what you need to do is start off with what we're given. So we're going to figure out, and I'm given 2 things. So I'm given 78.44 grams of carbon dioxide, and I'm given 32.12 grams of water. I need to isolate what's not in the other, because a hydrocarbon is C's and H's. So I probably want to figure out how much C's I have, right? And how can I do that? I start off with my carbon dioxide because I'm getting my C's off the carbon dioxide. I draw my T-chart. My unit goes diagonal, so that's 44.01 grams of carbon dioxide per 1 mole of carbon dioxide. And then I do my molar ratio. I have 1 mole of C per 1 mole of CO2. And that gives me my moles of C, okay? Then my H's, how do I get my H's? Remember, you wouldn't want the oxygen because the oxygen is in both places, plus a hydrocarbon is C's and H's. So once I do that, I get my 32.12 grams of water. Molar mass goes on bottom, that's 1 mole. And then if I look at this little compound, I have 2 moles of hydrogen per 1 mole of oxygen. So when I set that up in my T-chart, it gives me my moles of hydrogen. When we do empirical formulas, you have to divide it by the smallest calculated value. So because my smallest value is the 1.782, I need to divide both by 1.782. So what you should get is a 1 C per 2 H's. So your hydrocarbon is CH2, or your empirical formula is CH2. The molar mass of the compound was found to be 252.48. What is the molecular formula? So the way to solve this is you take whatever they give you, which is 252.48, and then you divide that by the molar mass of your empirical formula. So you take CH2, you get the molar mass, which is 14.03. And this is me adding these 2 together. And when you divide it, you get 18. So once you get the 18, it tells you that I basically have 18 of CH2s. So I would just have to multiply this by 18. So I get C18H32. And then what percentage by mass of the original sample was the hydrocarbon? So then if I'm looking, I have, and I'm looking at your CHs, right? I have 1.782 moles of C And then here I have 18 moles of C per 1 mole of C18H32. Now you could have done it, and it should equal the same thing if you just focus on the H's. Doesn't really matter. And then once you have the 1 mole, then you can get the molar mass, and then that gives you how many grams you got divided by your total grams, which was 31.25.